Good morning. Good afternoon, students. Today's topic is interplanar spacing. So, interplanar spacing is defined as the distance between the normal distance between the two atomic planes is defined as interplanar spacing, and this is denoted by the symbol S is D. So here you can say here a plane A, B and C. ABC is a lattice plane and it is intersecting the crystallographic x-axis at point A, and its magnitude is A by H, and crystallographic y-axis at B by K, and crystallographic z-axis at C by L. So these are A by H, B by K and C by L are the intercepts of this lattice plane made by the lattice plane along three crystallographic axes. Here, so you may ask one question that where is the another plane, another lattice plane. So we define that the normal distance between the two lattice planes we defined as a interplanar spacing. So you may ask one question that where is another plane. So here we have to imagine that another plane is passing through origin O. So this is another lattice plane is passing through origin O, and one more lattice plane is ABC. So this ON is the distance between ON is the distance between the which is equal to D between these two lattice planes O and D. So according to law of cosines, we can write law of cosines. We can write the cosines cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square gamma is equal to 1. So this one, sorry, cos square gamma is equal to 1, where alpha, beta, gamma are the interaxial angles made by these planes along these three crystallographic axes. So now how to find alpha, cos alpha. So cos alpha is ON is the normal drawn from origin O onto the lattice plane ABC. So ON is the ON. So cos alpha is equal adjacent side by hypotenuse. Now at point N, this is normal, is 90 degrees. So opposite to N is OA is the opposite one. So hypotenuse. ON is the adjacent side. So cos alpha can be written as ON by OA, where ON is equal to D divided by OA is A by H. So this is equation 1. Similarly, cos beta is ON by, that is OB, which is equal to D by B by K, is equation 2. And cos gamma is equal to ON by OC, which is equal to D by C by L, equation 3. Then substituting these three cos alpha, cos beta, cos gamma values in the cosine law, cos square alpha plus cos square beta plus cos square gamma is equal to 1. So we can get D by A by H, D divided by A by H whole square plus D by B by K whole square plus D by C by L whole square is equal to 1. So squaring this one, so we'll get D square, squaring and taking common, we will get D square into A by H whole square plus 1 by B by K whole square plus 1 by C by L whole square is equal to 1. Therefore, d square is equal to 1 by a by h whole square plus b by k whole square plus c by l whole square by whole square. Therefore, d is equal to 1 by root of a square by h square plus b square by k square plus c square by l square 1 by root of, which is the expression for interplanar spacing. And in case of simple cubic, simple cubic crystal system, A is equal to B is equal to A is equal to B is equal to C, then this will transforms to D is equal to A by root of h square plus k square plus l square. This transformed in case of a cubic system, simple cubic system. This is so where A is the lattice constant or lattice parameter, which is the units are in angstroms, HKL are the Miller indices. Okay, this is about the interplanar spacing.